Hello friends, thank you for your time to watch my video. Today we want to continue about kinematics. And this material is for your subject, physics. And if you want to follow the sense competition, I think this material is suitable for you to review. From kinematics, you have to study about scalar and vector quantities. I have already described what is scalar and what is vector quantities. Scalar quantities only describe the magnitude, and vector quantities describe the magnitude and direction. What is the example for scalar? Length, area, mass, distance, and speed. The example for vectors: displacement, velocity, acceleration, force, and thrust. The second unit in kinematics is about distance and displacement. Distance is the overall length that an object travels, and it's different from displacement. Displacement is the distance from the origin to the final destination. So what are the differences of distance and displacement? You also can see from the table. The notation for distance is d, and the notation for displacement is s. Distance is used to calculate distance and the total length of the object travels without considering the direction. And then how about the displacement? Displacement, of course, to calculate the displacement, the direction is taken into consideration. Distance is a scalar quantity, as it only depends upon the magnitude and not the direction. It's different from displacement. Displacement is a vector quantity, as it depends upon both magnitude and direction. Distance will give the detailed route information that is followed while traveling from one point to another point. Displacement refers to the shortest path. It does not give any complete information on the road. Formula to find the distance is speed times time. The formula to find the displacement is velocity versus times time. Distance has only positive value. It's different from displacement. Displacement can be positive, negative, even zero. Distance not indicate with arrow, but displacement we have to indicate with arrow. Distance can be measured along a non-straight path, but displacement can only be measured along a straight path. Distance depends upon the path, or it changes according to. It's different from displacement. Displacement does not depend upon the path, and it depends upon the initial and final position of the object. Unit number 3 is about speed and velocity. Speed is the rate of change of distance. Velocity is the rate of change of displacement. What are the difference of between speed and velocity? Speed is the rate at which object covers a certain distance. Velocity is the rate at which an object changes position in a certain direction. Speed is a scalar quantity. Velocity is a vector quantity. Speed can never be negative or zero. Velocity can be zero, negative, or positive. Speed Or we can say the average speed will continue to count even if the object changes the direction. The velocity of the object changes with the change in direction. Therefore, the object must follow one direction. Speed may or may not be equal to the velocity. An object possesses different velocity but the same speed. The unit of speed is in meter per second. The unit of velocity also is in meter per second. The formula to find the speed is v equals to d divided by time, where v is the average speed, t is the time taken to travel, and the distance is d, is the distance traveled. Formula to find the velocity is delta s over delta t. Delta s is the change in displacement, and delta t is the travel time. Unit number 4, that is about average versus instantaneous speed or velocity. I have already made the difference between the average speed velocity and instantaneous speed velocity. The overall rate of change of distance is the average speed, and the speed of an object, it is traveling at one moment in time is called instantaneous speed. So the overall rate of change of distance and the direction is the average velocity. The velocity of an object in a moment in time. The next unit in kinematics is about free-falling object, or we can say the free-falling due to gravity. Relate to the definition of free-falling. So free-falling object is the movement of an object or body only under the influence of gravity. A motion that happens when we let an object fall from a certain height. This motion only happens when the object falls because of its own weight, without any initial force or initial velocity. It can be illustrated when the object is falling from the height d with the initial position d0 and the final position is d, the final, or we can say df. And then the object is moving to the center of gravity without initial velocity. And the acceleration due to gravity is the same as the direction of the movement of the object. So we can apply the concept of kinematics to find the unknown in free-falling object. That is why I can put kinematics equation here. So the kinematic equation is d equals to vi times t plus 1 over 2a t squared. Vf square equals to vi square plus 2 times a times distance. Or we can say this the height of the object. Vf equals to vi plus at and d equals to vi plus vf divided by 2 times t. So with the condition for the free falling is there is no initial velocity or speed of the object. Means the object start from rest to move down to the center of the gravity. The next unit in our kinematics is about equation of linear motion. There are two types of motion in kinematics. First one is uniform acceleration motion, and the second one is uniform speed motion. Uniform acceleration motion, the condition for uniform acceleration motion is the path is in a straight line, and the object is moving with uniform acceleration. And if a body is under motion such that the amount of change in its velocity in equal interval of time will be constant. And the formula is the same like the free falling object formula. So there are three formula here. So Vf equals to Vi plus A times T. This is for the first equation motion. S equals to Vi plus delta T plus 1 over 2A delta T square. This is for the second equation of motion. And then 2AS equals to Vf square minus Vi square. And this is for the third equation of motion. Vf is the final velocity of the object. Vi is the body's initial velocity. A is the acceleration of the body. Delta T is the time interval or taken between the initial and final states. S is the displacement. S can be the height of the object or the displacement of the object. And the second type of motion is the uniform speed motion. What is the condition for uniform speed motion? The path must be straight line, and then the object is moving with constant velocity or speed, and the acceleration is equal to 0. There are only short formula here. Yeah, the first one is S equals to D divided by time, or V equals to S divided by time. S is the displacement, distance is D, and then this is for the speed of the object. For non-uniform acceleration motion, so this type of motion is defined as the motion of an object in which the object travels with varied acceleration. Means the acceleration is not constant. If a body is involved in rectilinear motion, and if the motion is not consistent, then the acceleration of the body must be not constant. The formula is different from the equation formula. So the formula is starting from the displacement versus time, and then velocity versus time, acceleration versus time. So if you want to find the velocity, so we have to find the gradient of the displacement versus time. So the formula is Vt equals to ds over dt. And then if the velocity is given, find the acceleration. You can follow the acceleration equals to dv divided by dt. And reversely, if you want to find the velocity when the acceleration is given, so you can use the formula v of t equals to integrate t1 t2 a t dt. Same thing, if the displacement is given or velocity is given, now you want to find the displacement, so the displacement equals to integrate t1 t2 vt times dt. So this formula is used for the non-uniform acceleration motion. So there are three types of graph of motion. First is position or displacement time graph. To consider the graph of motion, we have to consider about, also about the node. Any points give the instantaneous displacement. Gradient describe instantaneous velocity. For case number 1, uniform velocity for A, B, and C, which is A, B, and C. And then from the first graph or graph A, the slope is 0 and velocity also is 0. For the second graph or graph B, the slope is positive and velocity is constant and positive. For graph C, slope is negative, velocity is constant and negative. In position or displacement versus time, slope of position versus time graph is the gradient of the velocity. Again, the slope of position versus time graph is the velocity over that interval of time, or the gradient of the position of time graph is the velocity over that interval of time. You only find the gradient of the line. So if the graph is displacement versus time graph, so the gradient of the line is the velocity of the object or speed of the object. So it's different from the other graph that the position or the curve of the displacement versus time graph is a curved line. So from the graph D, slope is curved and velocity is not constant, means the object accelerating. So how to find the slope of the curve? You can take only one point on the curve and then try to find the gradient of the slope. Or example, if the function of position is given, you also can use this formula. Vt equals to ds over dt. So this formula is used to find the gradient of the position. Graph E, the object displacement is increasing at a decreasing rate, means uniform deceleration. Manually, you can find the gradient of the line. So for example, like this, or you can use this formula if the function of S is given. Graph F, so the object displacement is decreasing at an increasing rate, means this is the uniform acceleration. To find the velocity of an object when the object has the path of motion like this, so we can use this formula. Or just find the gradient of the line manually. For example, like this. And the last graph or graph G is the object's displacement is decreasing at a decreasing rate. Uniform acceleration. So acceleration is greater than 0. Same thing, if you want to find the gradient of the position of the object, means find the velocity of the object using this formula. So then you have to find the equation of S or use the traditional concept. The second graph is velocity versus time graph. There are some velocity versus time graph. The first graph is a constant velocity. You also can see the value of velocity is constant at any instance of time. So then we can say the constant velocity. If the velocity is constant, so then the acceleration is 0. So there is no acceleration for this graph. And the second one is the graph is a straight line, means the line increasing from the origin, so constant acceleration. And next, the second graph is increasing acceleration, means the curve velocity time is a open upward. And then the second graph is the graph is open downward, means increasing retardation. And then the last is the constant retardation like this. And then this is the decreasing acceleration. Note for you, any point gives instantaneous velocity. Example, if we take only one point, we can say that velocity is instantaneous. And gradient of the curve, the gradient on the curve will give the acceleration. So how to find the gradient? At equals to dv divided by dt. So this is the first differentiation of a function of velocity. And the area will give you the displacement. So as t equals to integrate t1, t2, vt dt. The last graph is acceleration time graph. There are only two graphs. First is uniform acceleration, and then the second one is non-uniform acceleration. For the non-uniform acceleration, it's very difficult for us to understand. Why? Because if you want to find the gradient on the curve, so we have to use the integration method. And then the second one is, yeah, if you want to use if you have to use mathematics. And then if you want to find the area under the curve, so the area under the curve will give you the velocity of the object. So what is the area under the curve? Means that is the integration. Now, for double integration, you also can find the area, you can find the distance traveled by the object if for the non-uniform acceleration. Again, the node is for the non-uniform acceleration. It's different from uniform acceleration. For uniform acceleration, you can also directly to find the area under the curve. So the area under the curve is the rectangle, depends on the time interval. And then also same thing, like the velocity versus time graph. Find the area under the curve. So the area under the curve is the distance or displacement of the object. The next is vectors. Vectors is one unit in kinematics. Vectors is a tool how to find the net of force or how to find the total or relative velocity. That is why we will discuss about vectors. So how to find the resolving vectors and direction. There are two types of method. First is analytical method, and then the second one is geometrical method. Analytical method, sometimes you can say the component method. That is why you have to describe or you have to find the component method of a velocity, and then after that you can use trigonometric ratio to find the vertical component or horizontal component. Let's say from the figure. From the figure, we also can find the vertical component. So the vertical component is equals to r sine theta. We can put r sine theta and then the second one is Rx. For Rx, we can also find is equals to R cos theta. And after that, if you want to find the magnitude of the resolving velocity, so we can use this formula. For the resolving velocity or resolving vectors is equals to the magnitude of r is equals to square root of rx squared plus ry squared. And sometimes we can find the direction of the resolving force or the resolving vectors or the resolving velocity. So this is the formula. If you want to find the direction of the net force, net velocity, or net vectors. Now here, we can put tangent theta equals to ry divided by rx. And then it's different from geometrical method. Geometrical method, we have to draw first And then we can use the protector to find the angle of theta. Or you can use geometrical method to find the angle of theta based on the questions. So we do not describe the component of each vectors. And then how to find the resolving vectors or resolving velocity. So the resolving velocity is equal to square root of a squared plus b squared plus 2ab cos theta. So theta is the angle between vector A and vector B. And then how to find the direction of resolving vectors from the x-axis. So we can put beta as the angle of the resolving force or resolving vectors from the x-axis is equals to inverse tangent b sine theta divided by a plus b cos theta. So that is the unit in kinematics. If you understand and then you try to make sure you understand the concept before we try to solve a problem related to the science competition or physics competition in your country. Thank you, everyone. And then don't forget, if you like this video, you can click subscribe, and then you can follow my channel. And then don't forget, click bell notification because I always give you the update about physics and mathematics, everything for you, materials, how to solve the problem related to physics and mathematics. And then we also can solve the problems in past paper. Thank you. Bye-bye, everyone.